You probably know the drill. Hit the gym, crush your workout, scoop some protein powder, shake it up, and feel like you just leveled up. But have you ever stopped mid-shake and thought, wait, who actually made this stuff? Believe it or not, that smooth vanilla-scented powder didn't start in a lab or an Amazon warehouse. It started on a farm. Yep, the same place your morning milk comes from. The story of whey protein begins long before the gym mirror selfies. It starts with cows munching away in the sun. Picture the scene. Sunrise over rolling green fields, mist still hanging low, cows lazily chewing breakfast like they've got nowhere to be, which, to be fair, they don't. What they are doing is producing the foundation of one of the most popular supplements on Earth. That fresh milk is collected through automated systems and pumped straight into giant stainless steel tanks, basically milk fortresses on wheels. Inside, the temperature stays cold enough to make a penguin comfortable, keeping the milk fresh while it travels to the processing plant. Once it gets there, lab techs in white coats run tests on everything: fat content, protein balance, purity, you name it. If the milk flunks a single test, it's out. No second chances. The good batches go into storage tanks chilled to near freezing, waiting for pasteurization. That's when the milk takes a quick, super-controlled heat bath. Hot enough to destroy bacteria, short enough to keep every nutrient intact. It's like giving milk a quick spa day. And then, the magic moment. A special enzyme is added, the milk thickens, and suddenly it starts to split in two. On one side, thick creamy curds, the beginnings of cheese. On the other, a golden watery liquid, the stuff we used to throw away by the gallon. That's whey. For centuries it was just dairy waste. Farmers would dump it, feed it to pigs, or let it flow down drains. Then someone realized this so-called waste was packed with fast-absorbing, complete protein. What used to be a problem became the product. From here, the real transformation begins. At this stage, the whey is still in liquid form. Imagine a thin yellowish milk with a faintly sweet, almost bakery-like smell. It doesn't look like much yet, but this humble liquid is about to level up. It's pumped through a labyrinth of futuristic filters, an intricate network of membranes so fine they could make a coffee filter cry. These filters act like microscopic bouncers at an exclusive club, only letting the protein molecules through while blocking out unwanted guests like fats, sugars, and excess minerals. What comes out the other side is cleaner, leaner, and far more concentrated, the good stuff your muscles actually crave. This ultra-selective process is the reason your post-workout shake ends up being pure, efficient muscle fuel instead of a gloopy, milky soup. It's a little bit of science, a little bit of engineering, and a whole lot of quiet precision, all working behind the scenes to make that one scoop in your blender bottle hit just right. Once filtered, the whey heads to massive evaporators that remove most of the water without overheating the protein. It thickens into a golden concentrate that looks somewhere between syrup and molten caramel. You could taste it, but it wouldn't exactly scream dessert. Now comes the part that feels like straight-up sci-fi: spray drying. The thick whey concentrate is blasted through nozzles into huge chambers filled with hot air. In a split second, the liquid transforms into fine powder, like snowflakes forming in mid-air. The sound, the heat, the sight of clouds of protein swirling under bright lights. It's like watching chemistry and art have a baby. That powder is cooled, sifted, and polished until every grain looks identical. Then it's bagged in bulk, sometimes 20 kilos per sack, sometimes half a ton, and shipped off to flavoring facilities around the world. This is the point where science hands things over to creativity. Inside those flavoring plants, massive mixers spin like jet engines. Workers pour in the pure whey base, then add flavorings, natural sweeteners, vitamins, and minerals. Each blend has its own personality: chocolate that tastes like milkshake, strawberry that somehow tastes pink, and vanilla, the undisputed classic. Huge paddles churn the mixture until it's smooth enough to pass a spoon test. To make sure no ingredient rebels and floats to the top, the entire mix is spun in centrifuges, basically industrial blenders on steroids. 15 minutes later, everything inside is perfectly uniform. No clumps, no inconsistencies, no excuses. Then it's showtime. The tanks tilt and the mixture flows into an assembly line that looks straight out of a sci-fi movie. Containers roll under filling spouts, and robotic arms measure the powder to the exact gram. Too much? Rejected. Too little? Rejected. These machines don't do close enough. When each tub is sealed, it slides down the conveyor toward labeling, the final identity check. Bright labels snap into place. Barcodes and batch numbers get printed, and suddenly, what was once milk on a farm has become something with swagger, your favorite whey protein brand. The smell of vanilla and cocoa lingers in the air like a gym locker with better life choices. But here's the part most people never think about, the precision behind it all. Every scoop you take has been tested, weighed, tracked, and traced back to the exact batch of milk that started the process. There's a quiet army of food scientists and engineers making sure what ends up in your blender bottle is clean, safe, and exactly what it says on the label. And while most people see whey protein as just a fitness trend, it's also a sustainability success story. A byproduct once dumped by cheese factories is now one of the most consumed supplements on Earth, a shift that turned waste into wealth, both for the environment and the economy. Once those protein tubs are sealed and labeled, the operation kicks into overdrive. Conveyor belts hum like an assembly line symphony. Robots stack, scanners beep, and somewhere overhead a red light flashes as another batch hits perfection. From here, every container gets scanned, weighed again, and tracked with a digital ID because one off-balance jar can mess up an entire shipment. It's a ballet of precision. Machines don't talk, but if they did, they'd probably sound smug. Yeah, we just filled 10,000 tubs before lunch. After inspection, the tubs are grouped by flavor. Chocolate over here, vanilla over there, cookies and cream in the back. Like a protein family reunion. Workers pack them into boxes, slap on the destination codes, and before you can say macros, pallets start rolling toward loading docks. Some are headed to local gyms and supplement shops. Others are off to ports, airports, and freight hubs, beginning their second journey, this time across continents. It's kind of wild when you really think about it. Something that began as milk on a quiet little farm might end up in a locker room in Dubai, a kitchen counter in Tokyo, or a gym bag somewhere in Toronto. One scoop powered by a global supply chain that connects continents, climates, and countless hands. But before those glossy tubs ever hit the shelves, there's one behind-the-scenes step almost no one talks about: shelf life testing. Every new formula batch goes through a miniature endurance challenge. It's exposed to humidity, heat, and time, all to see how well it holds up under real-world conditions. You could call it survival training for supplements. The powder's aroma, color, texture, and solubility are tested over and over to make sure that the very first scoop smells just as good and mixes just as smooth as the last one. It's quiet science ensuring your shake stays perfect, even months after you've forgotten when you bought it. And it's not just about longevity, it's about experience. Ever notice how some whey dissolves instantly in water while others clump up like wet sand? That smooth mix you take for granted is no accident. It's the result of hundreds of small tweaks, tweaking air temperature during drying, balancing fats for flow, even controlling static electricity in the mixing room. Yep, static. When you're dealing with powders this fine, one rogue spark can turn a factory into a snowstorm of vanilla dust. By the time it hits your hands, that tub of whey protein has passed through dozens of human checks and hundreds of automated sensors. It's chemistry, logistics, and obsession all rolled into one scoop. But here's the funny part. For all the tech and precision, it still comes down to something beautifully simple: milk. The same milk your grandparents poured over breakfast has become one of the world's most refined nutrition products. What used to feed calves now fuels humans chasing PRS at the gym, office warriors replacing lunch, or marathoners trying to recover before sunrise. The next time you crack open a fresh tub and that little puff of sweet protein-scented powder hits your face, take a second to appreciate what's behind it. That scoop didn't just roll off a conveyor belt. It's the final act in a full-blown choreography of farmers growing the raw ingredients truck drivers hauling them across states, lab techs perfecting the formula, engineers keeping the machines humming, designers making the label pop, and, let's be real, a few caffeine-fueled interns making sure the numbers add up. It's a quiet symphony of effort and expertise. Thousands of people who might never step foot in your gym, but still play a part in your next PR, your recovery, your grind. Every scoop is their invisible high five to your hard work. And when that shiny tub finally lands on a store shelf, it's not just another product. It's the end of a story that began with sunlight on grass and a farmer waking up before dawn. It's billions of micro decisions, from which cows are fed what, to how long each droplet spends under heat, to how your label gets printed, all so that tomorrow morning when you twist off that lid and scoop your serving, it just works. Smooth, fast, reliable. No drama, no thought, just fuel. So yeah, your post-workout shake isn't just some random powder. It's engineering disguised as nutrition. It's nature and science working on the same team. And now you know the full journey, from pasture to protein, from cows to containers. The next time someone asks why whey protein is so expensive, tell them they're not just paying for powder. They're paying for precision, for innovation, for a supply chain that treats every gram like it matters. Because it does. If you found this breakdown as fascinating as that first sip after a brutal set, hit the like button. Stick around. Science, machinery, and a little mystery blend together to create Spam. But forget what you think you know about canned meat. This is not a story about mystery meat in a tin. It's a cinematic journey through automation, innovation, and a magnified sense of tradition. Picture a race against time and bacteria, a perfect blend of old-school butchery and new-school robotics, where nothing is left to chance and every can carries a story. So buckle up. You're about to get an all-access pass inside the mega factory where millions of cans of SPAM are produced every single day. Picture Dawn, or breaking over a sprawling complex, trucks loaded with pork shoulder and select ham, their contents chilled and temperature monitored, rolling in just as the night shift finishes, scrubbing every inch of the facility to hospital-grade cleanliness. No meat enters this temple of engineering until rigorous quality checks are completed. Each shipment is scanned, sampled, and signed off. The journey begins with the selection of only the best cuts. Spam relies on premium pork shoulder for its soft yet firm texture, while the addition of ham brings a richness that's unmistakable in the final product. You may think all pork is created equal, but at this stage, even the smallest subpar detail means rejection. That's because making something as simple as Spam requires 1,000 layers of discipline, know-how, and absolute precision. Once accepted, those perfectly marbled hunks of pork shoulder and ham are transferred into the chilled prepping area. This is where butchery transforms from craft to science. Gone are the days of blood-spattered aprons. Now, skilled staff and machines work together in a serenade of speed and exactitude. Advanced cutters and pneumatic tools separate bone from flesh, slice away unnecessary fat, and portion the meat into just the right sizes. Workers and AI-powered vision systems double-check every step. Even the trimmings have a home. Anything not destined for this batch might find itself in another Hormel product, part of the company's zero-waste philosophy. Next comes grinding, and if you're imagining a kitchen mincer, think bigger. Each batch weighs in at about 8,000 pounds. That's roughly the weight of 2 city cars, churned through massive industrial grinders engineered for consistency. These powerful machines break the meat down, mixing the fatty cuts with lean ones, creating a homogeneous pink paste. Consistency at this stage is key. Too coarse? The final product won't have that signature bounce. Too fine? You lose the meaty texture that made SPAM beloved in the first place. And with every batch, metal detectors scan for any foreign objects. Safety isn't just a policy, it's wired into every action. But safety and quality don't end with grinding. Here's where Spam's secret weapon comes in: chilling and vacuum mixing. The freshly ground meat is mixed with crushed ice, instantly lowering the temperature. This ultra-cold environment does more than keep the batch fresh. It ensures the proteins won't break down or get rubbery during later processing. Inside the giant mixers, there's a literal vacuum, pulling all air out and further helping to prevent spoilage. This vacuum process is also crucial for another reason. It allows every particle of the mixture to bind together perfectly. So every slice of SPAM you eat is uniform from first bite to last. The benefits of vacuum mixing go beyond simple freshness and texture control. Removing air from the mixing chamber enables deeper seasoning penetration and keeps ingredient dispersal absolutely even, ensuring every portion tastes just as good as the next. This vacuum environment also aids in keeping colors bright and natural while locking in moisture, which leads to improved juiciness and shelf life. By reducing oxidation, the vacuum not only helps prevent discoloration and spoilage, but also intensifies the flavors and preserves the nutritional integrity throughout the product's long journey from factory to your table. All of this is achieved in a process faster than traditional techniques, minimizing processing time and maximizing quality. A perfect example of how technology and food science work together to create a global staple. Suddenly, the smell changes. It's time for seasoning and more science. Salt is added, not just for taste, but for preservation, ensuring no bacteria can survive. Sugar comes in to balance the saltiness, potato starch for that smooth, spreadable texture, a carefully measured splash of water to bind it all, and then sodium nitrite. This small but vital ingredient locks in the product's iconic pink hue and ensures that even after months on a shelf, the taste and safety endure. The exact blend of seasonings is closely guarded, part of the brand's DNA. Imagine the pressure in that control room. A single pinch off, and millions of cans could taste dull, salty, or, heaven forbid, not like SPAM at all. Meanwhile, technicians in spotless lab coats hover over sample lines, pulling shavings and spoonfuls from each batch. They run physical and chemical tests, checking color, pH, texture, and weight. If anything's off, computers alert the operation team, and the whole line pauses for troubleshooting. Efficiency counts, but perfection is the real factory law. All this, and you're only halfway to having a can in your hand. The now perfect meat mixture is whisked via ultra-clean stainless steel pipes toward the filling area, where automation takes over, ramping the process up to 90 cans filled per minute at peak operation. Each can is precisely aligned and filled, with cone-shaped nozzles injecting the measured portion in a single smooth motion. Sensors track fill weight and scan for air bubbles. Once filled, each can is vacuum sealed in a matter of milliseconds, sucking out every last trace of air before the lid clamps down. This vacuum seal is not just insurance against spoilage, it is the reason Spam's shelf life can stretch for years. Pause for a second and watch the ballet of machines as every can is stamped with key data. Production line ID, exact time of filling, and batch number. This level of traceability is key for food safety. If an issue is ever discovered, say with a single farm's meat shipment, every can be traced instantly and withdrawn if needed. This is modern food security at its best, but the drama isn't over yet. The next phase might be the most crucial: thermal processing, or what workers call retort cooking. Sealed cans travel into cavernous, industrial-sized chambers called hydrostatic cookers, some large enough to fit a city bus. Here, they're exposed to a carefully calculated mix of steam and pressure, reaching more than 240 degrees Fahrenheit. The objective? Sterilization and perfection. The heat denatures meat proteins, shrinks and binds them, and kills any bacteria that could possibly remain. But it's a delicate balance: too hot or too long, and the meat dries out; too little, and the product is unsafe. Banks of sensors and computers track every variable, adjusting on the fly even for the smallest fluctuations. At the end of their steamy journey, the cans are rapidly cooled, zipped through showers and baths that bring them back to room temperature in minutes, a necessity to halt cooking and keep the texture just right. Now they fly down the conveyor to be inspected again and again, both by humans and machines. Each can is rotated, scanned for defects like dents or leaks, and checked for proper sealing. The label application process is next, and in true factory fashion, it's another hypnotic show. High-speed rollers gently wrap Spam's classic blue and yellow branding around each can with utter precision. Shrink-wrapped and coated, they're robotically stacked into boxes and immediately sorted for global shipment. Think the story ends as cans are packed for shipping? Think again, because the logistics of SPAM are nothing short of Herculean. Pallets are automatically loaded onto trucks or into containers, bound for supermarkets, corner shops, military bases, and even remote Pacific islands. That's right, Spam's enduring popularity is owed in large part to how reliably and efficiently these logistical juggernauts work. From rural convenience stores in America's Midwest to high-end restaurants in Seoul, Spam travels farther than most people do in a lifetime. And the scale is astonishing. Spam's distribution network spans over 40 countries, with cans crisscrossing oceans and continents thanks to multimodal transport systems that blend road, rail, sea, and air. Specialized warehouses handle thousands of pallets, tracking inventory movements with advanced logistics software that maps out optimal routes for rapid, cost-effective delivery. Supermarkets, local grocers, and even online retailers eagerly stock Spam for its long shelf life and universal appeal, making it a reliable choice for families, restaurant chefs, and emergency food supplies alike. Whether you're camping off-grid, preparing for a disaster, or plating up brunch in a city cafe, Spam's journey reflects a rare mastery of the global supply chain, a chain that never sleeps, constantly adapting to meet demand and keep this iconic food accessible across every corner of the world. And let's not forget, the magic of Spam isn't just what happens inside the mega factory. Once those cans arrive in homes, the ritual begins. A pop, a hiss, the twist and slide of that perfectly pink block onto the cutting board. Whole cookbooks are dedicated to this stuff. In Hawaii, slices are browned and layered atop rice, then wrapped in seaweed to make musubi, a local snack legend. In the Philippines, you'll find it alongside garlic rice and eggs, a breakfast feast with deep roots. South Korean kitchens prize it so highly, there's a gourmet variety that costs more than some cuts of steak. British chefs stuff it in fritters, and American chefs post SPAM burger hacks that rack up millions of views. In every corner of the globe, Spam transforms from humble can to culinary hero, its story shaped as much by culture as by manufacturing. None of this would be possible without obsessive attention to quality and innovation. Every year, the factory upgrades its machinery, swapping older filling robots for new AI-enhanced models. Software gets smarter, predicting maintenance needs before breakdowns occur. Sustainability is always on the table. Any leftover trimmings are repurposed. Every drop of water in the cooling system is recycled. Solar panels and high-efficiency chillers keep the carbon footprint shrinking. Let's sneak back to the QA labs. Here, food scientists analyze cans from every batch, sometimes keeping archives for decades. Why? Because an off flavor found years after production offers a learning opportunity. Harmful bacteria and foodborne outbreaks are nearly impossible if processes are followed. But the factory's team never rests. They're constantly seeking ways to reduce sodium, test new spice blends, or even introduce limited edition flavors to global markets that now clamor for variety. In some markets, you'll find Spam with cheese, spicy peppers, teriyaki, or black pepper. Each gets its own run. Each is carefully manufactured as the classic. Let's zoom way out and marvel at the numbers. Every day, tens of thousands of cans roll off the line. In total, more than 8 billion since Spam's debut. That's more cans than people on Earth. The production is so relentless, the system so finely tuned, that a single ingredient truck arriving late could send ripples through supermarkets in 24 countries days later. But what really sets Spam apart isn't just the product, it's what it means to people. Spam was born out of necessity during the Great Depression, then earned its place as a lifeline in World War II, feeding troops and civilians alike when meat was scarce and shelf life was gold. It inspired generations of cooks, from parents prepping quick breakfasts to celebrity chefs who turn it into artful dishes. It became a symbol of resilience, ingenuity, and even rebellion. Across Asia, Spam became a delicacy after U.S. soldiers introduced it during war. In the Pacific, it's beloved at celebrations and on weeknight tables alike. Its durability made it a staple in disaster relief kits. Its unwavering quality made it the darling of home cooks, campers, and busy professionals in need of a reliable meal. So, next time you pass by that unassuming can in the supermarket, think about the technology, heart, and history crammed into every steel rectangle. From the vigilant eyes scrutinizing meat quality at 5 in the morning to the engineers and food scientists running round-the-clock shifts to guarantee safety and consistency, to the designers dreaming up tomorrow's flavors and eco-friendly packaging improvements, it's a world within a world, hidden inside an ordinary object you can hold in your hand. What's left to discover? Maybe a new recipe, a memory from childhood, or just pure, simple comfort when you open a can on a rainy day. But one thing's for sure, Spam made in a mega factory isn't just a miracle of food engineering, it's a symbol of how collaboration, science, and tradition can keep breakfast, and plenty of other meals, going strong for generations to come. Next time you crack open that can, you'll know the extraordinary journey your Spam has taken. From carefully selected pork shoulders on the farm through a meticulously clean machinist's wonderland, sprinting past robotic arms and steam chambers, and all the way to your fork. Ready for a taste? Because there's a whole history packed into every bite, a story of innovation, global culture, and that unbeatable pink perfection, locked forever in the world's most reliable little can. Ready to see the incredible journey of SPAM for yourself? Visit the SPAM Museum in Austin, Minnesota for fun, interactive exhibits, and inspiring stories from around the world. What if I told you that one of the most simple-looking gaming consoles on the planet is hiding some of the most advanced engineering we've ever seen in consumer tech? The new Switch 2 doesn't look like a spaceship. It doesn't unfold into a robot, and it's not made of unicorn dust. Yet somehow, Nintendo is asking you to cough up a cool $450 for it, a full 50% more than the original. So, what's going on here? Did they lose their minds? Or did they secretly reinvent how handheld consoles are built from the ground up? Let's step inside the world's most advanced gaming hardware factory and find out. At first glance, the Switch 2 looks almost unchanged. Same iconic shape, same detachable controllers, same overall vibe. It's like seeing your childhood best friend after a glow-up. Familiar, but sharper in all the right places. But under that familiar plastic shell, everything has changed. And the story of why it costs so much more starts with the brain of the machine, its processor. Inside the Switch, 2 lives a chip that would make even high-end laptops jealous. Built by NVIDIA using cutting-edge 4-nanometer technology, it's so densely packed with transistors that it's almost comical. The old Switch's processor was built on a 12-nanometer process with about 2 billion transistors. The new one? Over 15 billion. Imagine cramming the population of Earth twice into a space smaller than your fingernail. That's what we're talking about here. But building something that advanced isn't cheap. Creating a 4-nanometer chip involves extreme ultraviolet light, billion-dollar manufacturing equipment, and clean rooms so sterile they make hospital operating theaters look filthy. Each transistor is smaller than a virus, and they have to be etched into silicon with atomic-level precision. It's mind-boggling science, and it shows on the bill. That tiny brain used to cost Nintendo about $25 to make. Now it's closer to $85 per unit, and that's just one part of the console. Now let's talk about the screen. Most people expected Nintendo to go all in on OLED, since that's the direction tech usually goes. But Nintendo, being Nintendo, zigged where everyone else zagged. They went back to LCD, but not the same LCD from 2017. This is a next-generation panel with full 1080p resolution on a bigger 7.9-inch display, meaning over twice the pixel density of the original. It's also rocking HDR10 support, which makes colors pop and highlights explode off the screen in a way the OLED model never could. How? It's thanks to a quantum dot enhancement layer that lets the display render over 1 billion colors instead of the usual 16 million. But here's where the engineering brilliance really shows. This screen is not only more advanced, it's actually cheaper to produce. At about $35 a unit, it's significantly less than an OLED panel, while still delivering better performance where it matters. And because Nintendo opted for this tech, they could pack in features like 120 Hz refresh rate and variable refresh rate, both of which make gameplay feel smoother and more responsive without sending costs into the stratosphere. It's a classic Nintendo move. Don't chase the shiniest spec sheet, which yet build the smartest one. Then there's the Joy-Con situation. On the surface, they look unchanged, but anyone who's owned a Switch knows the original controllers had one frustrating flaw. Over time, they'd get wobbly, loose, and start feeling like cheap knockoffs. Nintendo was determined to fix that, and their solution is pretty genius. Instead of the old sliding rail system, the Switch 2 uses precision-engineered neodymium magnets to snap the Joy-Cons into place. These aren't fridge magnets, they're rare earth components that have to be aligned within 1/10 of a millimeter. Too weak, and the controllers fall off. Too strong, and you can't remove them. It's a delicate balance, and every pair is tested for up to 1 million attach-detach cycles. Of course, that level of precision comes at a price. The old attachment mechanism cost around $12 to make. This new magnetic system, roughly $35. But it solves a problem that's haunted the Switch since day one and dramatically improves the feel of the device. The difference might be invisible, but the moment you snap the new controllers on, you feel it. All of this extra power brings a new problem though: heat. The new processor is about twice as powerful as the old one, but it also generates roughly 4 times the heat. And heat is the enemy of handheld consoles. Too much of it, and performance tanks, components degrade, and the system becomes a pocket-sized furnace. So Nintendo had to get creative. Their solution was to borrow technology usually reserved for gaming laptops and high-end graphics cards: a vapor chamber cooling system with copper heat pipes. Inside, a tiny amount of liquid evaporates from the chip's heat, travels through the pipes, and then condenses back into liquid, a continuous cycle that wicks heat away far more efficiently than a basic heat sink ever could. Even the thermal paste that connects the chip to the cooler has to be applied by robotic arms with surgical precision. And every single heat pipe is pressure tested before assembly. It's overkill, but it's necessary, and it's not cheap. The cooling solution alone now costs about $25 per console, compared to just $8 on the original Switch, and then we get to the assembly process, the part most people never think about. Back in 2017, each Switch had to pass 23 quality control checks before leaving the factory. That number has more than doubled. Today, every single Switch 2 goes through 47 different checkpoints, each designed to catch microscopic flaws before they ever reach a customer. Robots handle the delicate steps like placing chips and applying thermal paste, while human technicians inspect for cosmetic defects and subtle assembly issues that machines can't detect. If a unit fails even one of those 47 checks, it's scrapped on the spot. Roughly 8% of all consoles never make it past the factory gates. This perfectionist approach adds about $40 to the manufacturing cost, but Nintendo knows it's worth it. A dead console on store shelves is a PR disaster. A flawless one becomes a household staple for a decade. They'd rather eat the loss on a failed unit than deal with the cost and reputation hit of mass returns later. And that's a big part of why Nintendo products, despite being handled by kids and tossed into backpacks for years, just keep working. Now let's talk numbers, because that $450 price tag doesn't come out of thin air. The original Switch cost Nintendo about $100 to $80 in parts. Today, the Switch 2 costs roughly $265 in materials alone. That's an $85 jump just in raw components. Factor in the more expensive chip, the new display, the upgraded Joy-Cons, the high-end cooling system, and the obsessive quality control, and the total manufacturing cost lands around $310 per unit. That leaves Nintendo with a profit of about $140 per console, slightly higher than before, but not outrageously so. Most of their profits still come from the games, where they make $15 to $20 on every title sold. But the price isn't just about hardware, it's about philosophy. Nintendo doesn't design products the way most tech companies do. They don't chase raw specs, they don't brag about teraflops, and they don't race to be the most powerful. Instead, they obsess over balance. Every engineering decision on the Switch 2, from the chip to the display to the magnets in the Joy-Cons, follows the same guiding principle. Give players the best experience possible without compromising portability, battery life, or fun, and that philosophy shapes everything about how this console is built. Take that 4nm chip again. Sure, it's powerful, but Nintendo didn't design it to run the latest AAA PC ports on ultra settings. They built it to deliver incredible performance efficiently. That's why, despite packing over 7 times more transistors, it sips power compared to traditional gaming hardware. It's not about brute force, it's about smart power. That's the kind of engineering that lets you play expansive open-world games on the go without your battery dying before the cutscene ends. And that's where a lot of the price increase really comes from. Invisible improvements, stuff you don't see in spec sheets or marketing slides, things like energy-efficient silicon, advanced power management circuits, and tightly tuned firmware. All of that costs money to develop, years of R&D, testing, and iteration. But the payoff is a console that's more capable without sacrificing the pick-up-and-play magic that made the original Switch so beloved. Then there's the display choice. Going back to LCD instead of sticking with OLED might seem like a step backward, but it's actually a masterclass in cost-benefit engineering. OLED looks amazing, no question, but it's expensive, harder to manufacture at scale, and not great for features like high refresh rates or HDR10 brightness. Nintendo's decision to invest in an advanced LCD with quantum dot tech means they can deliver richer color, higher frame rates, and better dynamic range, all while keeping power consumption lower and cost manageable. It's the kind of nuanced decision that seems simple until you understand just how much thought went into it. And the Joy-Cons? That's another perfect example of Nintendo's design priorities. Most companies would have shrugged off the looseness issue as good enough. After all, the original sold over 130 million units despite it. But Nintendo decided to tackle it head-on. Replacing a $12 sliding rail with a $35 magnetic system is a massive cost jump for something that, on paper, doesn't make the console run any faster. But in reality, it makes the whole experience feel premium. Every time you snap those controllers on, there's a satisfying click. They don't wiggle, they don't drift apart, they just feel right. And that kind of invisible quality, the stuff you can't put a number on, is what builds brand loyalty. Cooling is another area where Nintendo could have easily cut corners. They could have slapped in a slightly bigger heatsink, called it a day, and accepted some throttling under heavy load. But instead, they engineered a full vapor chamber cooling system, something you usually see in $2,000 gaming laptops, and shrunk it down to fit in a portable console. It's over-engineering at its finest, and it's why the Switch 2 can run more powerful games without turning into a space heater. So now the question's on you. Does Nintendo's obsessive approach to engineering justify the premium price? Would you pay more for something built to last and perform this well? Drop your thoughts below and make sure to... This is the PlayStation 5, a sleek, futuristic box hiding the result of one of the most ambitious global manufacturing operations ever attempted in consumer electronics. From the outside, it's a bold, iconic design. From the inside, it's a symphony of custom silicon, thermal science, and precision robotics. The journey of every PS5 begins with the brain, a custom AMD chip forged in microscopic layers of silicon. But what truly sets this console apart isn't just what it can do, it's how it was made. Building a PlayStation 5 isn't as simple as putting together parts in a factory. It's a high-wire act that stretches across hundreds of cities, with over 1,000 suppliers, and manufacturing facilities that run with the discipline of military operations. One hiccup, one delay, one single flaw in a component, and it can cost billions. This story is about how Sony built one of the most powerful consoles in history and how they did it using one of the most dangerous substances ever used in consumer electronics: liquid metal. At the center of this machine is the APU, the Accelerated Processing Unit. It's a custom fusion of CPU and GPU designed by AMD, based on Zen 2 and RDNA2 architectures. But this chip is powerful. Too powerful, in fact, for traditional thermal paste. In most consoles or PCs, a gray paste is applied between the chip and the heatsink to help transfer heat. But for the PS5, Sony needed something better, way better, and that's where liquid metal comes in. Liquid metal has a much higher thermal conductivity than traditional paste, which means it can move heat away from the chip more effectively. That keeps the chip cooler, the console quieter, and the performance stable even during intense gaming sessions. It wasn't an easy decision. Engineers debated the risks for months. Liquid metal, while efficient, is a finicky substance. It's electrically conductive, which means a single droplet landing where it shouldn't can fry the entire board. It's also prone to movement over time, especially when the console is standing upright for long periods. So if Sony was going to make this leap, they had to engineer their way around every single weakness. This wasn't just about slapping on a high-performance cooling material. It required an entirely new hardware ecosystem. Sony had to design a custom foam barrier to contain the liquid metal and prevent it from spilling beyond the chip's edges. That foam had to be precision cut and thermally stable. It couldn't shrink, it couldn't deform, it couldn't fail, ever. Then came the challenge of applying the metal itself. This wasn't something human hands could do reliably. Liquid metal smears, it oxidizes, it can't be handled like paste. So the solution was robotics. A highly specialized robotic arm was developed just for this task. Not borrowed from other manufacturing lines, not repurposed. Built from the ground up with one job: to apply this volatile substance with a level of care normally reserved for semiconductor fabs. The robot uses a tiny needle-like applicator to deposit the liquid metal in a perfect pattern across the APU surface. Not too much, not too little, just the right amount to ensure maximum thermal transfer while maintaining isolation from the surrounding components. It then spreads it using a technique that resembles micro-squeegeeing, leveling out the surface so there are no bubbles, no streaks, no missed spots. And this all happens in an environment that's sterile, temperature-controlled, and monitored down to the micron. Sensors constantly verify the placement, the amount, and the spread of the liquid metal in real time. If anything deviates from the target, or even slightly, the machine halts. It's that sensitive. Once the liquid metal is in place, the massive aluminum heatsink is lowered into position with robotic arms. Again, precision matters. Even pressure must be applied across the entire contact surface to avoid air gaps. Air gaps mean hot spots. Hot spots mean noise, throttling, or worst of all, failure. To ensure nothing moves during shipping, foam pads are also placed around the APU area to hold everything securely in place. This is critical because if the console experiences a hard bump during transit, even the smallest shift in the heatsink could lead to misalignment, and that misalignment could disrupt cooling. There's also a consideration for long-term usage. Liquid metal tends to settle over time. Gravity can cause it to pool unevenly, especially if the console is positioned vertically. Sony's engineers took this into account when designing the containment system. The seal around the chip ensures the liquid metal stays exactly where it's needed, no matter how the console is stored or moved. And then there's oxidation. Liquid metal can react with air or other metals, forming a crusty layer that drastically reduces its thermal performance. To fight this, Sony's system ensures the metal is fully enclosed, isolated from the environment, sealed in a vacuum-tight thermal envelope. In total, the decision to use liquid metal in the PS5 wasn't just about performance, it was about pushing the boundaries of what a home console could be. Taking something that had previously only been used by custom PC builders and integrating it into a global supply chain with millions of units in production. It was a gamble, one that paid off, because it allowed Sony to deliver not just a more powerful console, but a quieter one. A more efficient one that stays cool under pressure and performs without compromise. It's the kind of detail most players will never see, and that's exactly the point. The best engineering often hides in plain sight, but here's the thing, liquid metal is also electrically conductive. If it leaks, even in the tiniest droplet, it can short-circuit the motherboard. That's game over for the console. So Sony couldn't just slap some on and call it a day. They needed an entirely new process. They needed robots. Not just any robots. A custom-built robotic arm, equipped with a microscopic sponge barrier system, designed to apply the liquid metal with such precision it can't leak. The arm dispenses just the right amount of liquid metal, spreads it evenly across the surface of the APU, and then seals it in with a foam barrier. It's a surgical process. Most people don't realize this, but if a PlayStation 5 is stored upright for too long, the liquid metal inside can slowly shift and pool unevenly. Over time, that causes overheating, throttling, and performance issues. That's why the robots aren't just designed to apply the liquid metal. They're built to make sure it's placed in a way that will remain stable for years, even if the console moves, even if it's shaken, even if it's flipped. That's only one part of the equation, though, because once the APU and liquid metal system are in place, the rest of the machine needs to be built with matching precision. That happens in Kisarazu, Japan, home to a 30-meter-long robotic assembly line capable of producing one PS5 every 30 seconds. The factory is cleaner than a hospital operating room. 32 robotic arms perform the entire process, from motherboard assembly to final packaging. And every move is coordinated with ballet-like timing. No human hands touch the machine during assembly, but human engineers are always watching. They monitor the entire line, ready to intervene if anything strays from perfection. One of the most delicate tasks in the entire process is wiring. Flexible flat cables used to connect parts of the console used to be something only human hands could manage. But today, a 2.2-meter robotic arm does it faster and more precisely than any human ever could. It threads, folds, and places the cables with zero slack, zero waste, and zero error. Then comes the real heart. The massive heatsink and the liquid metal cooling system are mounted on top of the chip, locking in the thermal core. With the internals set, it's time to armor up. The iconic white side panels are injection molded and snapped into place. These aren't just for looks. The texture, the shape, and the vent placement are all designed for airflow, part of a carefully tuned thermal design. Every curve and ridge on the shell exists for a reason. It's built to keep the PS5 cool under pressure, and when that shell clicks in, it's a final seal on one of the most thermally efficient consoles ever made. But before a PS5 can leave the factory, it has to survive what some call the gauntlet. This is a brutal, unforgiving series of automated tests. Every port is checked, every button is pressed, the disk drive is tested, the software is flashed, then the console is powered on. And if a single thing goes wrong, it's pulled from the line. There are no spot checks here. Every single console is tested. That's not typical in electronics manufacturing, but Sony knows the stakes. A failure in the field isn't just bad PR, it's a broken experience for someone who saved up to buy one of these machines, and that's unacceptable. So what happens to the consoles that fail? They don't get shipped. They're analyzed, dissected, sometimes recycled. The margin for error is zero, and that's not a figure of speech. A console with a microscopic flaw in its liquid metal seal could fail 1,000 miles away in someone's home. That's why the robots in Kisarazu don't just build, they protect. All of this leads to a moment that most players never see. Finished, tested, boxed, the PS5s are loaded onto pallets and enter a global logistics network powered by predictive analytics. Ships, planes, trucks, all moving in sync. Sensors track every console. Routes are adjusted in real time to avoid weather, customs delays, or port congestion. Because when Sony does a global launch, they don't mean over a few weeks. They mean one day, one moment. A shared human event where millions of players from Tokyo to Toronto unbox their console together. But all of this, all the robotic precision, the silicon engineering, The thermal mastery, none of it starts with an assembly line. It starts in a room, a meeting, a whiteboard. That's where the lead system architect, Mark Cerny, begins. Every new console starts with a list of things the previous one couldn't do, a wish list, a backlog, but more importantly, it's in a conversation with the developers. The ones building the games. They say what they need, what held them back, what they want next, and sometimes those meetings are brutal, but that's where the breakthroughs happen. One of the biggest requests? An SSD. Developers had been begging to ditch the rusty, spinning media of hard drives for years. Game data, models, textures, animations, was being bottlenecked. That's why PS5 uses a custom NVMe SSD with a read speed 5 to 10 times faster than what developers even asked for. That means no more elevator loading screens, no more narrow passageways just to hide background loads. Fast travel that actually is fast, but an SSD that fast needs a matching data pipeline. That's why Sony built a custom I/O architecture with invisible compression. Developers don't even have to manage the data compression or decompression. It's all handled by a dedicated unit in the custom chip. The result? Games are smaller but more detailed. Subnautica dropped from 14 gigabytes to 4 gigabytes. Control, Ultimate Edition, was cut nearly in half. Miles Morales, even with higher resolution assets, ended up smaller on PS5 than PS4. The same level of obsession went into the CPU. 8 Zen 2 cores, not just for better graphics, but for smarter AI, more responsive physics, and richer simulation. In games like Returnal, there are thousands of projectiles on screen at once. In Destruction All-Stars, the vehicle deformation is handled by the CPU in real time. Even though some devs wanted 16 cores, they backed off when told it would shrink the GPU. Because the GPU, that's where the eye candy lives. The PS5 GPU is a customized AMD RDNA 2-chip running at 2.23 GHz with 10 teraflops of compute power. That translates into realistic lighting, detailed skin textures, and subtle facial animations that just weren't possible before. It also supports ray tracing, something that wasn't even high on the wish list because developers didn't think they'd have enough horsepower to use it. But Sony delivered, and at their very first PS5 showcase, 6 games already used it. Ray trace shadows, reflections, global illumination, it's all here. Then there's audio. PS5 includes a dedicated unit for Tempest 3D audio. This isn't just better stereo. It's full spatial audio that creates a feeling of presence, like sound is actually coming from around the player. Rain sounds like it's falling in the room. Footsteps in the distance feel directional. And it doesn't require special headphones. Any stereo set will work. Even the controller, the DualSense, reflects this same philosophy. With adaptive triggers and haptic feedback, players can feel the difference between pulling a bowstring and firing a gun. When a weapon jams in Deathloop, the trigger physically locks. When riding a horse in Ghost of Tsushima, the feel of stone versus mud comes through the vibration. All of these features come together in one seamless experience, but none of it works without that custom robot in Kisarazu, quietly applying a bead of silver liquid metal no bigger than a matchstick head. Because in the end, perfection isn't just about power. It's about the invisible details, the stuff no one sees, the parts that make it feel like the future is in your hands. And that's the real secret. The PS5 is a machine built by machines, but it's made for people. The robots build the console, but it's the human connection, the midnight unboxing, the first button press, the shared moment across time zones that gives the PlayStation 5 its soul. Thanks for watching. For more deep dives into the engineering, design, and storytelling behind the world's most iconic tech, hit that subscribe button. Like, comment, and share if you learned something new.